Hey, so we're back, Matt and Matt Butcher. Say hello to the viewers.
Hey, everybody.
And I know you're brand new, a couple weeks in here, and you're just like drinking water from a fire hydrant, right?
From a water blaster.
But anyways, let's continue, jump right in on our conversation relative to thermoplastic and cover some more things, just kind of maybe move to some summary items. I will say there's a lot of things that we're not going to have time for in this conversation. Things related to proper sizing of thermoplastic lines, coming to the pump, coming from the pump. How do we get good starts and stops? You know, we learned a lot along the way about the volumetric, the volume of a thermo knife cavity, you know, might have, let's just say 15 cubic inches inside that cavity. Well, let's say if your knife gate was, well, be ridiculous and say your knife gate was 10 cubic inches. When that knife gate moves up to start a line, you're displacing 3/4 of the thermal, you're gonna have a big splat, right? So getting the speed of your truck, the speed of your knife opening, the sequencing of your pump maintenance speed versus your pump boost increase, because you know the pump moves at and creates a maintenance speed, and then when you open a gun, you've got to make that pump spin faster, and there needs to be like a delay between the gun opening and the pump spinning up, you know. And anyways, a lot of very detailed conversation. We spend hours, days talking about all of those details, but we're focused today on really just basic process of melting and mixing and pulverizing material, and how we're converting a 1.4 million BTU flame and getting that heat transferred into the plastic through oil. So just moving towards summary, you know, some of the benefits kind of our system, separating the process into a two-part process using oil instead of, we're still using 2,000 degree fire to heat the oil, but that oil is moving at 20 miles an hour through those tubes and sucking up that heat and then carrying it and very gently heating. We're heating plastic with 1/4 the temperature of conventional style. We're never heating that plastic with 2,000 degrees. We're heating with maximum 500 degree oil, right? And so you never create charred material. Our filters in these units are little tiny filters. They're designed to catch watches and wedding rings. You know, they're not designed and built with these huge to catch tons and tons of burnt and charred material being scraped off the bottom of the kettle, right? And so that in itself is a huge benefit. But we talked about 255. I'm just going to move through some notes, so pardon me if there's some redundancy there, but 255 square feet instead of 28 square feet on competitive systems. We talked about the heat exchanger and how the heat exchanger is 122 square feet by itself. And by the way, it holds only 209 pounds of plastic. That's 1.7 pounds of plastic for each square feet. So, you know, transferability of heat. Let's say on a traditional kettle system, you're not going to use yellow today, you're only going to use white. Can you dismount your burners from the yellow side and put them over there on white for the day temporarily? Ridiculous. Obviously not possible. Can you do that on a Thermo Hog? Yes, you just shut your oil valve off to the yellow side and boom, you're concentrating all that 1.4 million only on white. Means you never have to flush a kettle so that you can use both sides on one color, because you have that same heating capacity, which I'm told that sometimes customers use 2, 3, 4 tons of material to flush it out so they can use all 4 kettles on one color. Mixing, we talked about mixing. Clumping is a big issue with vertical kettles. The bricks or blocks, just chunks float around and turn along with the mixer. This design pulverizes and crushes and lifts and lets fall and does a really terrific job of pulverizing material very quickly when it's coming in. Of course, then we're dumping that superheated material from the heat exchanger on top of it as well. In fact, I think we recently did kind of a animation that shows kind of the process, the oil coming into the burner, getting hot, traveling through the shell side of the kettle, traveling up then through the shell side of the heat exchanger, and how we're then the complete system, incoming bags, superheated material falling on top of those bags, etc. So then also loading, we discussed loading. You're loading at your feet instead of 12 feet in the air, no steps, one person only, no conveyor belts, 2 kettles, never 4, so there's no drop down platforms and walking material back those platforms. You know, the moment you drop those platforms, you drop both sides at one time, you're literally 4 feet over legal width. What happens if a guy does that, no traffic coming, but then he's got a problem getting that thing back up, and you're striping and now you're 2 feet over width, the semi coming by? I just see that as very dangerous. I don't know why it's accepted, but it's been accepted for many years. How about this one? This is a huge thing. It was never possible to put heat exchangers above the kettles on our vertical systems, right? The vertical systems, if you put the heat exchanger above it, the thing would be 18, 20 feet tall. But because these lateral kettles are so low to the ground, you're standing on top of them. So you can see that the heat exchangers are mounted over top of the kettles. Why is that important? Well, because at the end of each day, and I think we've got a shot of it here where the guy just opens up the ball valve at the bottom of that kettle and literally allows any glass beads or plastic to drain by gravity straight back down in the kettle. This prevents any of those tubes from getting clogged over time. Oh, I thought, James, that you said that you can't create charred or burnt material, so I didn't think I had to worry about that. No, it won't create burnt or charred material, but glass beads can settle out in those tubes. It won't melt them, but they can still impact and prevent molten plastic from flowing. Hog speed control. Very easy to engage and disengage this, simple push of a button, and your speed control is controlled electronically instead of your operator by hand and foot. What about low center of gravity? We haven't talked about that, but instead of having these giant weights way up in the air like that, you now have very low center of gravity, even weight distribution across that truck.
When I was out this weekend, I don't mean to cut you off, but when we were traveling from the yard out to the works and we were in, the guys were commenting that the ride is much smoother, right?
Wow,
around curves, getting onto the highway, and they attributed it to that.
I'm so happy you're already out and about, like intersecting with clients, customers, operators out there is so important. Kettles extending all the way to the rear truck eliminates so much plumbing, Matt. There's literally no plumbing between the kettle and the knife gate, between the knife gate and the pre-screen filter, between the pre-screen filter and the pump, and between the pump and the final filter. There is no plumbing at all. Simple connections using the sanitary connections. So to change out a thermal pump, super easy. 1 burner, not 9 burners. We haven't said that before, but MRL, Aero's latest trucks, they got 9 burners on them. We got 1 burner, not 9. So keeping your glass eye cleaned and keeping that burner tuned and running properly, much easier. Still only 2 hot oil pumps on our truck. How about the insulation? I mean, look at this. These things, when they're coming together, are so easy to insulate. We got 3 inches of insulation all around these things. The heat holding capability insulation is tremendous. What about core diameter? We haven't touched on this, but the core diameter, you take some of these kettles out there, our vertical kettles were almost 4 feet around, okay? 4 feet around, you're 2 feet from heat in any direction, right? And so what about the core diameter of a 22-inch pipe? It's 11 inches maximum. The bottom, the top, the sides, not to mention the fact that our vertical kettle designs and all the other people's vertical kettle designs have so much welding in them, so much welding, tons of welding, right? What is this? It's a seamless pipe. There is no welding inside of here. The welding is at the ends and it's on the outside. If it were to ever breach, it would be where you can see it, where you can get to it and access it. Spray, extrude, profile guns available, as well as multi-shoe single gun with many patterns available. That's on every single mini hog we've made, is you have so many different options. One cavity all the way across, 1 hose flowing to it. You can have, just almost unlimited variety of patterns coming out of that gun. Pointer bar, laser, cameras with crosshair generators for line guidance. What about the fact that you cannot overfill this? You can't overfill it. The chute is not heated. So if you pack bags in there, they're just not gonna go down in, but it's not like they're gonna melt and the material's gonna start overflowing. You can't overflow the device. You can't overfill it. How about the fact that there's never been any storage or room for tools and storage on a thermo truck? Check this truck out. Look at the doors open all the way around. Look at the Hog tool system on this truck. And I think we got a walk around video at the front pad where you can see a really nice open area of these trucks, how much storage there literally are on the trucks. Hey, so with that, what we're gonna do is, we got a truck down here right now, Matt, that's been sitting for about a week. I think the yellow side's about 3/4 full, white side's about half full. We're gonna go down and from a very cold start, we're gonna start up that truck. We're gonna let you, the viewer, see how easy it is to start this truck up. How do you do it? Well, first you just turn the key and start the truck. There's no PTO on our trucks now. We got rid of it. I freaking hate PTOs. I know it's a strong word, but PTOs are just been one of our pain points, honestly, especially on the Thermo Hog. Why? Because when you're going down the road, you want to be able to heat while you're going 70 miles an hour to the job site. That means that PTO is going to be turning at a very high rate of speed, right? But when you're stopped at a stoplight, guess what? It's still got to run there. So we end up using these giant pumps that can't be spinning too low at a stoplight and can't be overspun going down the road. And it's not been easy, but we've got past all that. We designed, developed our own system where we have an auxiliary engine driving the air compressor and all the hydraulics necessary to run with no PTO. I love it. You start the truck, turn your power switch on, go to the back of the truck, start your air compressor. Then you turn your hot oil pumps on. You got 2 hot oil pumps, your main and your extremity. Once you've done that, you're gonna monitor, you're gonna turn your burner on next, right? And then you're gonna monitor your temperatures. And here you see a picture of the startup screen, and you're going to look at your yellow heat exchanger temperature, your yellow kettle temperature, your white kettle temperature, your white heat exchanger temperature. Of course, those aren't gonna move. The heat exchanger temperatures will not move until you're up and running and recirculating material through those heat exchangers. And then you have top right-hand screen is your hottest oil. That's the oil coming directly out of your burner. Your next is your oil set point. We recommend set 550, but you can set it up to 570, 580. You really want to push it? Push it. Not to hurt anything. The flash point of this stuff is not a 675, so we stay way away from that, more than 100 degrees, okay? And then you have your main oil tank temperature, and then you have your extremity oil tank temperature. And so I'm excited. We're gonna get to see like the timeline of what it takes. And what we're gonna do is we're gonna show you the starting temperature, which you already see here. And then every 15 minutes, we're gonna show you a screenshot of what that temperature is doing. Every 15 minutes, so here you see the 15-minute right now. And next you're gonna see the 30-minute. And then you're gonna see the 45-minute and 1 hour. And it's gonna take us about, I'm gonna estimate 3 hours. And once we get past that 3-hour mark, you're gonna be melting at 9,000 pounds an hour. So let's see what happens, and I'll see you on the startup, and looking forward to it. You out there in viewer land, if you want to see this thing in action, come to Hog Day Rodeo. I don't know how we're going to do it, but we're going to put on a really impressive melting somehow we just gotta like melt plastic and dispense it out into containers or something, because we want you to leave Hog Day Rodeo with the absolute conviction that yes, I saw 9,000 pounds an hour go in and come out of that device, all the while temperatures increased, material was mixed homogeneously, like no lumps, no unmixed material, no clumpy, lumpy mess, you know.